Okay, so looking back at our 5-number summary again, something that jumps out at me is the distances between these quartiles. Take a look, for example, at the median again. Now we know the 50th percentile is the divider, which means half of the years on record have fewer than 9 deaths per year, and the other half have greater than 9 deaths per year. But what we can also think about is fewer than 9 has a bottom limit. The bottom limit is 0. There were certain years in there where nobody died in avalanches. So that means 50% of all of the years on record had between 0 and 9 deaths. Looking at the other side of the data, the other half of the data had more than 9 deaths. What's the maximum number? Well, it was 36. Look at those ranges. From 0 to 9 is only 9 years, but from 9 to 36 is 3 times as long. But you got to remember, those two ranges cover the same percent of years in our data set. Statisticians have given us a couple different ways to visualize this. One is the histogram. So if we scroll down and look at the histogram again, you can see that if you identify where 9 is on the graph, you can see that half of the data is to the left and half of the data is to the right. Now some of you might be sitting there going, how can you tell that, Sean? Well, one way is you could actually go and add all those individual little frequencies. But a better way is to use a tool that statisticians have invented, something called a box and whisker diagram, or sometimes just called a box plot. Now, Excel lets you make a box plot, but the way they do it, well, let's just say it's not that user-friendly. I've created one. It's kind of clunky. I can't make it yet integrate in with this histogram. So what I've done is, you have to do a little bit of customization on it. If you scroll over to the right, I've got it hiding over here. This right here is a box and whisker plot. It's not done yet. We have to do a little customization. So what you're going to do is you're going to grab it and pull it. Make sure that when you grab it and pull it, you're grabbing in the white area of the chart. That way you're moving it. Okay, and this is the part that I'm trying to figure out and I haven't quite figured out yet. You have to make it so its horizontal axis matches the one down here. So the minimum X value I've got in mind is 0 and the maximum is 40. So what I have to do is right click on this, format the axis, and change those numbers from 0 to 40. And when you do that, you can close this now. What happens is the box plot, or the box and whisker, shows up on top of your histogram. All right, and now you may have to do a little bit of adjusting. Like I think I'm going to have to scooch this over a little bit to get those 40s to line up on the far right side. But now your box plot's on top of your histogram, and I'm going to go ahead and turn off its axis, so all I see is the one axis on the histogram. What are we looking at here? Well, that leftmost point at the end of the box and whisker plot is the minimum value, just like the rightmost point is the maximum value of the data. Let's go back to the minimum. That line running to the right of the minimum and ending in that green box, that represents the range of the lowest 25% of data. So you remember what that range is by looking at the 5-number summary. It's 0 to 4 deaths. So the minimum is 0. That line that it bumps up next to is 4. 25% of all the data lives in or along that whisker. Now, starting at the end of that whisker and the beginning of that left green box, moving all the way to that vertical line there, that's the next 25% of the data. The left line is 4 deaths per year, and the black line coming down is the median. That's 9 deaths per year. So that's a little bit wider than that lower whisker. Then the next box, which is again even wider than the previous one, starts at the median and goes out to the 3rd quartile. That spans 7 deaths, and that's the next 25% of data. And then at the very end, way out to the end is the maximum. Those are the 25% of years with the most deaths in the entire data set, starting at Q3 and going up to the maximum. So you can see what's happening with this box plot compared to the histogram. It's showing you the skew of the data. The left side is very, very tight by comparison to the right side. So what you get is you get this cool visual in a box plot of what is actually going on skew-wise with the data itself. Now I want to come back to this avalanche data in a second, but I also just want to show you how to make the adjustments in this box plot for different data sets. So let's take a look at that next. The first thing I'm going to do is I'm going to delete all this just by selecting and then hitting delete. Zeroes out the graph, zeroes out the box plot as well. I guess that's what it looks like when it's zeroed out. And then I'm going to go back to the other spreadsheet that we pulled the AVI data from and go over to Pasteable Datasets. And I've got a couple data sets in here. One is I generated both of these data from parameters. We're going to study the bottom one, the number of female hens in a flock of 20 chickens. We'll study that later in this class. The top one is I generated this data from the parameters that I pulled off of that CDC growth chart. This is 2-year-old white American male head girths in centimeters. So you can just select all this data, copy it, and then paste it over here. So I'm going to stick it up top left corner, paste, drop in. All right. Now, what happens is, unfortunately, when you drop it in, the graph down here doesn't update automatically to these the new data values. So you have to kind of dork with it a little bit. So I'm going to look at here. The minimum here is a 37. The maximum is a 51. So I'm going to make the minimum be, I don't know, 35, and the maximum be, I don't know, 51. Or 55, maybe, 55. That looks pretty good, okay? And if you can tell, right over here, it says, it's not really skewed. Not really skewed at all. Now, the problem is this box and whisker is completely looking at the wrong place now because the data that we have in this data set is much higher than the other one. So I'm going to turn the axes back on, and then I'm going to go in here and format them, and I'm going to change my min and my max to match that. There. Now they match. There we go. I'm going to close her up. And if you want, you can turn the axes back off now once you've got them match it. All right. So now you look at the box and whisker, and it's actually sitting directly on top of the histogram. The maxes are lined up. The mins are lined up. The medians are all lined up. It all looks pretty good. It all looks pretty good. Now, as far as the skew, you can tell by my handy dandy pretty basic skew checker that it's not really skewed data, which it's not. It's not perfectly bell-shaped by any stretch of the imagination. But that center part of the data where most of the data is, that correlates just about to where the box on the box and whisker plot is. And those two whiskers, one of them isn't obscenely long compared to the other one. That implies that you've got a tail off of either side that are roughly symmetric. So symmetry is kind of given by the fact that that box is centered and the two whiskers off to the right and left sides of the box and whisker are roughly the same length. Are they perfect? No. But statistics is not about perfect data. Now, let's go back to the other one. I'm going to delete all this data out of here. And let's grab the kind of skewed data that I've got in here. So this is the number of female hens in a flock of 20 chickens. And like I said, we're gonna get into this and have some fun with this later in the class. I'll paste this in right here, paste the values in. Okay, and again, we got to adjust things up. So looking at the minimum's 12, the maximum's 20. So we'll go 10 to, oops, that's the number of bars. We'll change that back to 15. We'll go 10 to 20 first, and we'll start there. 10 to 20, okay, and that looks pretty good. It's a little bit messy. Maybe we'll go with 10 bars. That's not bad. For some reason, the max value is cutting off at 18. This is one of those weird things I was telling you about. So let's bump it out to 22. Yeah, okay, this is one of those weird little glitches that I haven't quite figured out with Excel yet. But this is not bad, because what you're seeing really doesn't matter what I set this top to, whether it's 22 or 21 or 20 or whatever. You're seeing the skew, right? You're seeing the skew on the graph, okay? And the skew checker is right there with you. It says it's kind of skewed. But let's get that box and whisker and take a look at what it looks like. So I'm going to turn the axes back on, and I'm going to edit the axis so that it starts at 10 and goes out to 23. All right, and there she is. All right, this one might take a little bit more finagling to get to match up because there's definitely something going on with the max on the histogram. So here, we'll kind of troubleshoot it right here. That looks pretty good, actually. So now you can see this looks like a mirror image of the AVI box and whisker plot. You've got that crazy long whisker on the left side and that tight whisker on the right side because this data is skewed to the other side of the way the AVI data was. Most of the data here is on the right-hand side of the graph. With the AVIs, most of the data was on the left-hand side of the graph. So that's kind of one of those indications that a box and whisker plot can tell you. Each of those regions is 25%, every single one of them. but the stretching of the regions can actually give you a pretty good visual of the skew of the data set.